good afternoon. Sorry for my voice, I'm still recovering. And I would probably start with small prompt injection. And yes, I work at Amazon, but I do not represent Amazon during today's talk or afterwards. So I will tell you about my story, but not about Amazon products, customers, business, whatsoever. With this being said, let's get started. Today I will be speaking about the attacks on enterprise AI, and specifically I will be talking about probably the most prominent use of AI in enterprise, the chatbots, LLM-based agents, and so on. And there are plenty of approaches how to secure the implementations, and Dr. Nick Allott earlier today shown the picture with a bunch of different standards. I already picked my favorite one. It's OWASP top 10, and I will be I'll base my speech on this standard. But let's first start with what is an adversarial attack itself. So basically, an adversarial attack is a technique that leads to unwanted results, unwanted by a regular user or wanted by an attacker. So if the attack is successful, it can lead to, for instance, security breaches or PR issues or financial losses. And there are multiple types of adversarial attacks, but most of them are based on either prompt injections or data poisoning or excessive agency or all together. And the fundamental question, why LLM-based enterprise systems are susceptible for such attacks. Arguably, it is because LLMs cannot reliably distinguish between the commands, the prompts they need to follow, and the data they need to passively process. We will cover that later. But the underlying problem, underlying issue, is the models are just not smart enough to make this separation between command and data to process. So let me start probably with a very brief overview of all top 10 risks, and I will dive deeper into three my favorite ones. All of that is available on the website. It's OWASP top 10. Moreover, they have just recently released a dedicated guide for agent-specific attacks. And I believe one of our next speaker, Helen Oakley, she is a key contributor to that guide. So I highly recommend you to read it as well. So let me start with prompt injection. So again, its vulnerability lead attacker to trick LLM system into providing unwanted outputs, right? And it can be in passive mode. So for instance, I can type this malicious request, or I can embed some poison data in your knowledge management system and trick your AI system indirectly. Another way of tricking the system is sensitive information disclosure. For instance, you've got a pre-trained model and you fine-tune it on corporate data, and you don't realize that it can leak to someone without explicit access to this data. It can be a problem for you. So you need to really understand what data the model is trained on and what is your fine-tuning data set. And the third risk is a supply chain risk, and I believe Helen Oakley will cover it in more details. But essentially, modern AI systems, they consist of many third-party components, and even if your core module are safe and secure and covered by type bomb, you can introduce another model or another module that is affected by some of those risks, and it can compromise all your system. The fourth one is the data or model poisoning. So essentially, if I seed the training data with some misleading information or with some poisonous data, it can, of course, affect the outputs, the inference of LLM and of any system that is based on it. The fifth risk is an improper output handling. For instance, if your system allows you to convert plain language, plain text into SQL, right? It's pretty common example of such systems. And if you don't handle the output properly, it can lead to SQL injections, for instance. Then risk number 6 is excessive agency. Comes in all types of flavor. So when you allow system to do automatic activities beyond the intended scope, and I will dive into that later in my speech. Seventh is system prompt leakage. System prompt is essentially how you guide your system to react on users' inputs and requests. It can have underlying logic, it can have all the guardrails, how to respond, how to not respond, and if this information becomes available to an attacker, they can devise further attack knowing this underlying information from the system prompt. The eighth risk is vector embedding, vector or embedding weaknesses. So essentially, it typically affects retrieval augmented generation systems when either the data is poisoned or you convert the information into vectors, and then on retrieval stage you allow malicious actors or users without defined set of permissions to access this data. The ninth one is misinformation. Basically, it's kind of overlapping with model and data poisoning. You can embed some malicious data there and spread misinformation across the enterprise. For instance, leading to some team to be perceived as underperformers, for instance. And the 10th one is unbounded consumption. What it leads to, it can lead to excessive computational power usage. So I can deplete your financial resources, or I can replicate, crafting the very specific requests to your system, I can replicate the underlying logic behind your model or behind your system prompts, or both. So I can kind of distill knowledge from your system. All right, and as I said that I will focus on my personal top 3. I find them highly relevant to the LLM-based copilots and knowledge management agents. So, and the first one is a prompt injection. It comes in two broad types. So it's direct prompt injection or indirect one. So direct is when I'm, as a malicious user or attacker, use prompt to directly influence the behavior of the system. For instance, I'm asking the system to ignore all previous instructions, or ignore the system prompt, or leak some hidden information to me, or perform unwanted actions whatsoever. Another type is indirect prompt injection. And for this kind of attack, I need to put an information into the enterprise system. For instance, I can create an article in Confluence, or alter multiple Confluence pages or wiki pages, enterprise wiki, and add the information that will mislead the retrieval augmented generation. And So there are like several approaches how to mitigate these risks, right? You can build like a very robust knowledge graph, but the truth is, like at the moment, I don't see very like robust protection from the indirect prompt injections. So if you are able to access the enterprise knowledge management system, and you are able to create data points there, you can like mislead any type of decision-making system based on LLM. However, it doesn't mean that we should not like do anything. There are still mitigation strategies, but most of them are based on the constraints. For instance, some implementations I'm aware of, they just limit the set of users for such systems, right? So just this team use this specific agent and will log all their activities, what they do, and we do not let anyone else beyond those set of teams use the system. It's kind of protection by limitation the scope and the impact and the access. It has its own drawbacks, right? You cannot boost the performance of the whole organization, but at the moment, it can work this way. Sorry. Probably in the future, we will be able to train LLM systems to help them like better prevent this prompt injection and better like follow the embedded guardrails by enhancing the training data. But at the moment, not so many we can do, even with knowledge graph. The second problem, like the very like has a highlighted risk, is excessive agency. What it means is when the system you are operating with has permissions well beyond the intended scope. So probably an agent has permissions like to not just get the data from the system, but also update or insert or even delete some information. It happens during the development, so we want to test the agent like in the most broad spectrum of tasks to see where it fits into the like business value chain. But once we like release it to end users, we need to make sure that the set of constraints is there and its agency is actually limited to the use cases we want to. Or, for instance, like we create an LLM application that should operate within the context of every specific user and use your basically use your credentials and the file you have access to. But somehow the system is created with a much more broad access. So it operates well beyond the scope of individual user access. You should be wary of that. And you should, of course, check that the execution is tied to the user who is operating with the system. The third, and probably the most dangerous part of this excessive agency is when some critical actions are performed without human in the loop and without the explicit approval of the user, right? We have seen that in many enterprise implementations that the whole spaces of data just were deleted or were updated with some malicious information because we didn't rely on human in the loop. We still need to do that. Yes, as I said, the mitigation strategy exists. So you need to execute in user contexts. You need to minimize extension to the reasonable level, right? So and all of those extensions should have very specific permissions, and they need to be checked frequently because use cases are constantly updating. You release the application, it has access to just one space, let's say in Confluence, but once you start adding more and more information, the agent itself becomes more and more, I would say, dangerous, right? So you need to re-evaluate what it has access to and how it can affect your enterprise. And at the moment, I believe we need to limit the ability of agents to self-start tasks, right? Especially if the scope is not limited to very specific activities. Of course, you require user approvals for mission-critical tasks. And the third risk I find highly relevant is system prompt leakage, like Edward Snowden behind me leaked a whole bunch of critical information. The system prompt also contains critical information about your system, about how it works. Basically that's a logic behind the system, what it's allowed to do, what's not allowed to do, what capabilities it has. If this information becomes known to an attacker, they can devise further attacks. And your system, now it's not a black box for them, right? It's rather like they have this information, and all further attacks will be based on this knowledge. For instance, like what kind of roles your system has, or what kind of permissions your system allows, what kind of information, what is the decision-making flow for your system. And even if they don't have access like to verbatim system prompt, they can infer it and can infer the parts of this prompt. It is still pretty dangerous. So the idea how you can prevent this risk: don't put like your key logic into the system prompt. Especially if it's about verification or credentials or user management. Use dedicated systems to do that. Don't let LLM or like your system prompt to handle this kind of mission critical activities. Implement guardrails and really you need to rely to avoid reliance on system prompt, at least now. Easter eggs will not help. I added that just to check your attention, but Easter eggs, yeah, definitely they are not very helpful in this specific context. So the basic idea why we have been talking about that. If you know what to expect, if you know that your system can be attacked from like multiple angles, and the attack area is really large, you can understand what kind of constraints or defenses you need to implement to be protected, or at least to limit the blast radius. And that's it from today.